Yo, yo, yo. And welcome to another stream where we're going to try and recreate terrain. And it looks something like this right now. Some sort of candy land. Good morning, good morning. Wish. I do wish I could pronounce that name. I've seen it so many times, right? Good morning, Geralt. Let's see if I can actually try. I'm gonna do my best. With this. Ooh. That's a pretty name, right? The question is Ikitete Erai, maybe. What's up, Kangtran? How are you doing today? Okay, so yesterday was, how should I put it, frustrating, but also I learned a lot. The good thing is that we managed to get the correct normals right at the end of the live stream. And we can see here we use the same algorithm, the same approach to both of these. Still wonder why. Yeah, okay, so this is way more high resolution. Oh wait, is it? Yeah, it is. So when we calculate the normals, we use more specific points, I think. We use, when we calculate a, let's see if I can show this. When we calculate the normals for this point, we don't check the neighbors in the texture, we actually check the vertex neighbors. When we calculate the normals here, we don't actually check the vertex neighbor, we check the texture. And that's why we get a little bit of a more smooth result here, which I think is just fine. So the question today is, maybe we want to try and solve the seam on this approach. So in this approach, the seam problem is already solved. Here we still got it. And then I've also been thinking of how exactly to handle the height difference at the seams. I'm a little bit worried about that one. Let's see if I can pull up a texture and try and explain. And let's open up, we have a 64 times 64 noise texture, I think. Let's open that one up. So, I have a little bit of a problem. Let's open up this one as well. And then we do canvas size, maybe, width 128, size, and then we take this one and put it here. So the whole problem with the seam is did I seriously take a looping texture? This one ain't looping, right? Let's see. Yeah, let's hide this one, duplicate this layer and move this one over here. There we go. So the problem with the seams comes from the textures that holds the terrain data, right? So if we create, like, let's assume that these two blocks are separate terrain patches. So we use this data texture to render this terrain patch and this one for the other one. When we set the vertex height for this at this position, then we pretty much need, or actually when we set this vertex height, we need information from the other patch. And that's easy to solve if you're working on the CPU. Good news, it's also relatively easy to solve if you work with texture arrays like we do, although we have opted for a solution to not, at least not create the normal texture in the shader, but we do offset the height. So the question here is, the easy approach would be to solve it on the CPU. Just update the terrain data texture and the terrain normal texture with the help of neighboring patches. And then we don't need to do anything special here in the shader. Or we could do it the hard way and fetch additional information here. But then again, that will lead to more texture reads, which is bad, and more calculations in the shader, which is bad. Now, like, we want to do as little calculations as possible here. We also want to send as little data as possible. And like the terrain, the character, the player will change the terrain. So we only need to update the data textures when the player does such change. But it's a little bit of a problem here concerning this, which I've thought about. So let's assume that we just update this on the CPU. So when we create these data textures on the CPU, when we set the edge value in the texture, this one for instance, we need to take this one into account. How exactly, like when we render on the GPU, then we want a vertex for this patch here to be the same height as a vertex for this patch here. And the really the only way to do that, if we're not going to read from neighboring textures, is to have this pixel value be the same as this pixel value. That unfortunately means that we're going to have... This is going to result in two neighboring pixels having the same values. Like, we're pretty much forcing the seams to be two consecutive pixels having the same values by doing it this way. And it honestly seems like that might be the only way. Am I gonna have a better time trying to visualize this in Blender? Maybe I think I will. Let's see if we can open up Blender and do something here. Let's delete it all. Okay, so this is two different patches, and what we want to happen when we read from the texture, we want this vertex for this patch to align with this vertex for this patch. And as I mentioned previously, that's easy to do if you have access to that one's texture, or if the texture has the same value. I think I'm just gonna say fuck it, and we're gonna try, and on the CPU we're gonna try and symmetrize these two textures, or like we're gonna make this pixel value the same as this pixel value. We're gonna make and see what kind of result we get. Maybe it won't be, like at lower resolutions it will be noticeable, at higher resolutions it won't be as noticeable. But I think this is, we have to do it this way, I think. And then we're gonna have to figure out if the cons, like if the con is big enough for us to review it and maybe do it in another way. I would love to be able to visualize this problem better, to better explain it. Yeah, so I think we're gonna do some calculations here in set neighbor. When we set a neighbor here, we're going to alter both the neighbors and this texture. Ah, fucking hell. We also need to remember that if we have it like this, we have to do it in such a way that this, and this pixel has the same value. Terrain patch stitching. That one is another problem as well, but that should be fixed if we do it the texture way. Okay. I don't really see. So basically, when we stitch this on the CPU, we will read this value. We will read this value, and then we will recolor these as like the average between those two, and they will have the same value. Or or you add borders to the textures. So each patch actually only has 62 times 62. It's in this case, so their texture is actually 64 times 64, but the edges contains information about the neighboring one. Does that becomes pretty much the same thing, right? No, probably not. That is probably the best solution, because, and then when we generate pixels like vertices, if we generate a vertex here for this patch, read the name, yeah, maybe that is the best solution. Fuck, I need a good way to visualize this as well. But that would mean that, let's see here, when we generate terrain base indirect, and we generate the UVs here, we actually do I plus 1 here, or we start with 1 here and we go to less than resolution subdivided here. Or we don't do it here, but we do it for the UV here. But then we can't use UV here. What's up, Render Goblin? The fun indeed. Yeah, you know the struggles, right? This is a solved problem, use empirical knowledge. Yeah, please share. I'm open to information, I am. Please share. Yeah, redundant data is the key, and you don't need perfect normals. Yeah, perfect normals is... Yeah, we don't care about perfect normals, that is true. And like the problem we're having now, we do get sufficient normals. I'm happy with the normals. The problem we have right now is just exactly how we want to... we generate the normal, or we calculate the normals on the CPU and store it in a texture. And then we read that texture in the vertex shader. It's just a problem of how exactly we want to solve these seams when it comes to normals. Like, there exists two approaches as I see it. One will give some artifacts, or one approach will affect the visuals of the terrain, or it will add constraints to the terrain basically. The other one won't. I do want to visualize this problem we're having, or what we're trying to solve, to better make you understand exactly what we're sitting with right now. There are several options. Lucky basics, you don't have to solve the seam problem on every individual chunk, or you can simply pack the normal data into Vertex. We cannot pack the normal data into Vertex. That is not possible with our current solution, because we render our terrain using instancing. So we're basically rendering 16 terrain chunks, but all of them has the same mesh. So we just render one mesh at 16 different positions. And then we do some magic in the shader to make them appear as different terrain chunks. Does it make any sense? So we actually send 16 times less vertex data down to the shader, or even more, I think. So instead of sending, let's see here, instead of sending 4 million vertices to the GPU, we send, what is it, 250,000, and then we just render this one 16 times, basically. It's beautiful. Thanks to this little call here. It's very nice. I don't know if you saw it last week, Render Goblin, but if we only relied on like vanilla terrain, doing everything on the CPU and sending how much information we ever want, like we have normals is a solved problem, terrain patch stitching is a solved problem, but not with this new approach. I send 17 times 17 verts to the GPU and it's blazing fast with instance rendering. Yeah. I use one 512 texture. So you use one 512 times 512 texture. Do you recalculate the normals every frame then on the shader. I guess like that 512 texture, is it height data only, or is it height and normal data? And how exactly do you solve your seam problem? Yeah, I guess maybe. Yeah, what the fuck? Maybe I'm... Yeah, we could solve, like, maybe right now we're using terrain or texture arrays, but maybe, like, instead of just having arrays, maybe we should just pack them all into a big texture. That way we don't even need to care about seams, to be honest. Maybe that's the best way. So you generate the normal in vertex shader. Every frame you generate the normals in the vertex shader. So that basically means that... And how many do you do? Do you need 4 texture reads per normal, or how many texture reads do you do per normal? Yeah, we currently pack it into texture array. I'm thinking we might just go with texture, to be honest. But... What's up, Cypher? What's up, what's up? How are you able to recreate normals with only 2 texture reads? That's crazy. Did I screw myself by using texture 2D array here? The good thing with texture 2D array is we can you approximate normals. Yeah, of course, but how do you approximate normals with only 2 texture reads? Doesn't make much sense to me. 4 texture reads. I don't even know if it's possible with math magic. You're gonna get very bad approximations. Or am I missing something? Want a screenshot from my engine? I would rather, like... I have seen it, I think. I don't doubt that you have good normals. I just wonder how the hell one approximates it with only 2 texture reads. Like, if you have a height map like this and you want to approximate the normal for this vertex, same way you're doing it with 4. So 4 would be this one minus this one minus this one, and then cross product. How the hell would you do it with... So with 2 you just do this one and this one. But then you only get the slope in one direction. Only sample forward. Only sample forward, no need to sample behind. So, like recreating normals using 4 texture reads would be this. Left minus right, cross product up minus down, right? Oh, thank you. Let's take a look. I'm very interested, very interested. Float H, float R. That gives you good enough normals for terrain. Very interesting. Depends on what you're gonna do with your terrain, right? Is this right and this is top? Test. So this is the height for the current pixel. Okay. But this result would... So, like, the reconstructed or the approximation of the normal is always going to be right top tilted, right? Like, yeah, I guess it's always a question of what you want to lose. Like, what information do you want to skip when it comes to approximations, right? And this approach pretty much nullifies the left and bottom influence over the normal. The formula uses positive and negative numbers, and triangles are drawn in whatever order you want. Yeah, I see that, like, this is a possible solution to approximate your normals. It's just... fuck, does it remove a lot of information. Lol, not really. I don't see how you don't lose information. Is your terrain going to have extreme jumps between every vertex? Probably not. Okay, I do understand, like, this is a good enough approximation, but like, to say you don't lose information is... I'm trying to figure out, like, if you have a pixel that is a peak, pretty much. This one maybe. Like, the normal should be more straight up, but if you only take these into account, you're gonna get a slope downwards here, right? Okay, yeah. Good enough kind of thing, yeah. And how do you solve the tangent? How do you calculate the tangent as well, or do you do the fake tangent approach? I'm wondering if I should probably... Tangent is easy since the terrain tiles are grid aligned. Oh, that's probably true. Okay. Although I think I'm pretty dependent on good normals, because we're gonna do grass generation later on. Depends, we'll see. But like, I think I'm gonna continue with generating the normals on the CPU for now, and just read one texture value. But what I'm thinking now is packing this as texture to the arrays might be a bit overkill. So I don't know how it will look in the future, but the terrain in my game won't be too big, I don't think. So what I'm thinking is, instead of Mm. One sec, just need a coffee. Like I wonder, like instead of storing this as a texture 2D array, we might just store it as a texture 2D, a big texture 2D, and keep neighboring patches together in a nice way. Maybe that's the best way to do it. That would solve the stitching as well. There are lots of options. I chose less memory bandwidth option of doing the normal in the vertex shader. A few dots and sample in the vertex shader for a tile that convey plenty of pixel words. Yeah, that's true. It's always like what you want to support and not support. So here's, when it all comes down to it, what I want to support with this terrain is quick terraforming, pretty much. That's the main purpose. Then you will want to generate normal. Yeah, probably true. Definitely true. Yeah, you're definitely true. So as you edit, there's no CPU time wasted generating the normal, and it's not work for the GPU to do it in the vertex shader. Yeah. The way we're gonna do the edit as well is just altering the that is definitely true. Normals are commonly approximated in a vertex shader with water as well. Then detail ripples are added with the little ripple texture in the pixel shading. Yeah. Yes. Okay. We're probably gonna move on to moving this from the CPU to the GPU in the future. But for now we're going to keep it like this, and we're going to flatten this array. We're going to make it into one big texture 2D, I think. The height data needs to be both on the CPU and the GPU, I think. If you go chunked LOD, you're basically treating terrain like a bunch of object meshes. Do you have any like write-ups or like all this information you're telling me? Where did you get it from? Like, if you have any references to any papers or stuff like that, it's highly appreciated. Yeah, like the actual terraforming is just going to be one texture applied to another texture. Like it's going to be let's see here. We're going to solve the terraforming, like the changing of the height textures is going to be solved in a similar fashion as this right here. We're just going to solve it with a blit, basically. So we're just going to take it's going to be the terrain data texture. We're going to apply like some paintbrush shader to it and apply a second texture to it. And then we need to read the pixels back to the CPU because we need it for collision detection. But it's going to be extremely fast, I think. But yes, okay, so the first thing I want to do today is probably to flatten these. So instead of in the shader, instead of reading the terrain like this, text to the array, we're gonna need to sample a texture using UV, but the UV is gonna be offsetted based on which patch it is. So one sec, we're gonna indirect shader. Okay, so what I'm gonna do is, we have a pretty good solution here. We have a good halfway solution. So I'm just gonna commit this as it is right now. We're gonna try the approach by flattening out the arrays. And by doing so, it's going to be easier to recalculate the normals on the GPU as well. Okay, so I think that's a pretty good approach for today, or to-do list. So let's see here. Terrain shader indirect, and then we want terrain indirect here, but we can clean this up a little bit before we commit it. So or actually patch indirect. I don't think we need this one nor this one right now. And I think we can delete this for now. Let's make it, yeah, let's delete it for now. Just make everything run quicker. So this is a CPU based terrain, slow, and then we have garden indirect here. Okay, let's see if that one works. Okay, beautiful. Okay. So let me just commit this real quick and we're gonna move on. So it is the, let's see here, terrain shader indirect. Yes. Geometry clip maps is the way I want to go. Okay, I'm just gonna save that down in my notepad. Look into it after this stream. Might help me as well, you know. Okay, so now we have the current instanced indirect solution is committed. So let's take a look now. So instead of storing this as an array makes it harder to look up information in neighboring patches. If we just store this as a big texture, instead, it might work out for the better. So it's still going to be the same amount of data, it's just going to be bigger in an X and Y direction. I don't know what's preferable actually. Then you simply have to worry about the seam problem at the distant edges. Yeah, that's true. So if you use MIP maps, we're gonna have some seam problem, right? But I still think it's okay. Right? Yeah, it should be okay. And for now, we're gonna calculate the normals on this CPU as we have done, just to see if we can get the same result but with flattened terrain data arrays here. Fuck, the more we work with this, the less sure I am that I want a terrain patch indirect data here. We might want to skip this one actually. I don't know if we need this class status. But it is nice to hold data like this. I think we can simplify this so much. Height range is going to be the same for all of them. I'm using C++, so it's easy to know how much data is being held or made or whatever. Yeah, it should be easy here as well, although I'm not that well versed in it. But we're gonna find out soon enough. But I do want neighbor references, that's true. Yeah, the garbage collector. Yeah, we're gonna have to worry about that later on. But night should be okay. We'll see, we'll see. It's good to keep all of these things in mind. Okay, I pretty much want to restructure how I use this. Did we change something here? Okay. That is a big win indeed. Okay, so I'm thinking this. I think I want to remake terrain patch indirect. We don't need dimension or resolution or delta here, I don't think. Or do we? Lucky for us, the GPU don't care how we manage and feed the texture data, but we might care if we don't keep the instance textures organized. That is definitely true. And I think organizing it as a 2D texture instead of a texture array is... it's like... it shouldn't even be a question about it. Like, one 2D texture is way better. But let's see. So, first of all, I'm gonna start I'm gonna start by creating a simplified terrain patch indirect. So we have terrain patch indirect. Fuck. Or should I just change this one? So terrain patch indirect is more going to be just a data holder or data container. It's not going to have this much functionality itself. I wonder I don't even think it will keep track of its neighbors itself. Instead we will just let terrain base handle that. So I'm wondering if I should just do one patch to rule them all indeed. I think let's see, public struct terrain patch indirect data. Are we gonna change this one? No. It's like height range. All patches are gonna have the same height range. Terrain data texture, we will only have one in the base patch. Yeah, let's skip this for now. But what I want here, though, I think, is public int. Do I want to call it X? Like I still want its index, right? Or IJ might be better. Let's just name it like this for now. And we do. So this is like the index in the big patch grid. Yeah, we have a lot of problem here now. So in terrain base indirect, we're gonna work directly with this, I think. That's the better approach. And now we probably have, yeah, some issues here. And we have terrain patches IJ here. Let's comment this one out. So new terrain patch indirect. No, we're gonna have data. And this is how we're gonna store it now. And everything we need here then is ij position. Terrain data texture like this. That's not what we're gonna do. Yeah, let's save this one for later. ij here is going to be instance specific variables as well. I think. Much like this. Private texture 2D, just terrain data. So one big texture, and it's gonna be as big as, let's see here. Dimension is world distance, basically. Resolution is number of vertices. And then we might want to have terrain data resolution as well. Let's go. I'm starting to think that might have been a better option to just start with a fresh file. vertex resolution subdivided, and then we want texture resolution subdivided. And these are only going to be used to properly read it. To properly read from the correct part of the texture in the shader. We'll see. Actually, we want this one up here as well. I think. So, let's see. In generate, what we do first is we calculate the correct subdivision. So subdivision is 2 to the power of whatever is decided to be its subdivision. The dimension subdivided. The question, vertex resolution subdivided, texture resolution subdivided. And then we have delta here as well. Then we create a set of terrain, or we create the terrain patch matrix. We calculate the position based on dimension subdivided and total dimension, and then we create a terrain patch indirect data struct with the indices and the position. This one is used to create a translate, rotation, and scale matrix. And we need one of those per patch. And that's pretty much all we do with this one for now. And then we create the mesh in question. So each patch is actually going to use this mesh to render itself, but they're gonna vary thanks to instancing and stuff like that. So then it's up to this one again. But first of all, we need to create terrain data. So this is the big texture 2D. So this is pretty much this one, but we represent it as texture 2D instead of texture 2D array. So let's see here. This is no longer going to be the case with this approach, and that is very good. So, okay, let's create terrain data first of all. So I wonder if I want to do it in generate. Let's do it for now. Terrain data, new texture 2D, texture resolution .x, texture resolution .y. MIP chain probably want one, but for now we're going to say false, and we're going to represent data in this texture, so linear is true. And this is where we're going to use this one. So this is just a way to get, so we have an array of terrain data textures, each are 64 times 64, and we just get a random, or not a random one, but we loop through that array and get different ones. And so what we need to do now is we need to pack this one into this one in the correct place. And I think we want to do it with, where do we have that one? Terrain base, no, terrain patch. I thought terrain data container. Here, we basically want to do this, I think. Terrain base indirect, so we get a terrain data texture. Now I'm manually gonna set it up so that subdivision times the size of this one equals texture resolution. So we don't get any mismatch there. But so render texture temp. Is this how we want to do it? Actually, can we just blit it? Is this a bad way to go about it? I appreciate it. Let's see, we can do it in this is just a bit more optimized way to do it. At the moment I'm using world chords for the instance, so it maybe that's Let's see, we can do it in a worse way, I think. Let's see here. Int k is equal to 0, k is less than terrain. What's up, agent cr? Terrain data texture dot width k plus plus. I need to get my terrain converted back to sector code so I can get my 256k times 256k map area open again. That's insane. For int l is less than okay, so basically we just want to put this data into this one at the correct place. So terrain data dot no set pixel so that's I multiplied by resolution, actually texture resolution subdivided dot x plus k. Yeah. And we do j times texture resolution subdivided dot y plus l. And then the color in question is going to be terrain data texture dot get pixel kl. And that's about it, I think. $256 kilometers is noob engine though. I want 40k kilometers for that full Earth size terrain sim. That would be insane. I'm over here. I'm probably gonna settle at 1 kilometer maybe. But I do want that ultra fast terrain terraforming, you know. This math, I don't know if it's correct, but we'll find out eventually. Easy peasy. Yeah, I'm pretty sure. And then we do this. And then we're... Yes, okay, so now it's how we want to send this data, how we want to read it and stuff like that. So we're gonna change terrain patch. Oh, that's not the one. Terrain shader indirect. So Unity sample text to the array LOD. We don't want to use this one. We want to use, let's see. First of all, I think we want It's not like you will be editing the entire 1K at any moment, right? So yeah, your instance chunks and editing little windows in the texture, you will be golden. Hopefully we will be. So here I wonder if we want a float for... Do I just want to call it... maybe I do. We want one of these. And we want... Maybe not the best name, to be honest. IJ. Yeah, maybe rename those in the future. But let's see here. No, that's not what we want. That's not what we want. Let's see. What's up, Cooler SK? Yeah. Terrible names. Yeah, like, I agree. Let's see. Instance X, instance Y. Yeah, like I would prefer X and Y here, but it's actually X and Z then, and then it becomes a little bit of a mismatch on the CPU side, and when you work with textures. Like the vertices are in the XZ plane, the textures are in the XY plane. It's a bit of a mismatch, so then you have to find, yeah, it's fun. Naming variables is not fun. Let's see here, CG program Unity read texture 2D. Yeah, it's DirectX. Let's see. I have this very good. Let's see. Unity, writing, custom shader. I'm not entirely custom shader fundamentals, please. Yeah, okay. So I'm not that used with CG program. I'm more versed in HLSL. So it's a question of, let's see. Unfortunately, we can't go HLSL right here. Or we can't do it as we usually do, because we need some stuff from in here. Yeah, it's a little bit of a mess. Like, I haven't worked that much with this before, so... Mesh normals, can we get a texture? Texture shader example, there we go. So how do they want us to... The fuck? A procedural, yeah, we want... Sampler 2D, thank you. There we go. Sampler 2D. And then we just sample it by doing text 2D. Is that how we want to do it? Yes. Oh, you're going with sed up in your engine. Yeah, that's an interesting choice. Sampler 2D main text, we're gonna call this terrain data texture. And let's see here. return float for 1111. We don't care about normal right now. Okay, so we should be able to read this like oof. Do I want to read it like float height value is equal to, what was it, text to, actually we want to create, let's do float to UV is equal to float to. So I wonder if we want to name I multiplied by float to texture, or actually UV delta, texture delta. Yeah, we're gonna have to go through this and rename everything later on. So I wonder if we want to do texture delta I instance ID multiplied by texture delta dot x plus input dot uv dot x. And j instance ID I don't know. Yeah, we can probably just save it as, like, we could do this on the CPU. Yeah, we're gonna clean this up later on, but for now we just need to send, like, we can calculate I times texture delta and j times texture delta on the CPU and just send that in instead of I and j. It all depends on if we want this information down here later on or not. But plus input.uv.y. So input UVX, input UVY, this is pretty much, so this is the UV coordinates local per patch. And but then again, actually, never mind. So this is between 0 and 1, and we need to make it, oh, fuck me. This is not at all what we want to do. Lol the brain indeed. We'll see. This is not at all what we want. But we pretty much want, let's see here, float vertex xy in, okay, let's see, let's just name it I. We want input.uv.x multiplied by texture delta.x, but not texture delta.x. We probably want something like UV delta. Okay, so if we have a terrain patch like this, U and V for one of these is going to go between 0 and 1. And if we want to read this part of the entire texture, we want a UV delta. It's basically going to be this. So in this case, the UV delta is going to be 0.25. So we want I times UV delta, right? So if I is 0, we don't do anything. If it's 25, we get to here. Then we do plus this one, so UV dot X times UV delta. Yeah. And then we want to do the same in this direction as well. I think this is how we want to do it. So I is like 0, 1, 2, 3, 4, whatever. Okay, so that's how we want to do it. So UV float 2 is going to be I instance ID dot or times UV delta, and then we do input dot UV dot X times UV delta dot X. And we pretty much want to do the exact same thing here. But with J and Y instead. And then height value, we read it by text 2D terrain data texture UV. Try this. So what you're saying is scale is equal to 1 divided by hard-coded 512, and then we do sample very specific. Yeah, of course. But let's see here. I'm pretty sure this would work as well, right? Sure, depending on what delta is. Oh, that's definitely true. Yeah, I'm pretty sure this would work. Let's try it. I think we're ready to try this soon. But I'm gonna use that one. UV delta is something we need to send in, and this one as well. So UV delta is basically 1 divided by subdivision, I think. Everything here is kind of a fucking mess right now. Come on. What the fuck? UV delta. And then we do 1.0 divided by subdivision dot x. And then we do I'm pretty sure we can fix this. Like, we can clean so much of this away later on. This is very explicit. I think we can even calculate like UV delta. We can pretty much calculate it in the shader based on this one. Yeah, whatever. Subdivision is your variable for patch size. Yeah, now like subdivision is basically the number of patches we have. So we have world size of the terrain, how many vertices in each direction of the terrain, how big the textures representing the terrain is, and subdivision in each direction, or actually a subdivision constant. This is for the full texture, or for the full terrain. This is the full terrain, and then we use all of these to calculate what each patch should have. Okay, let's see. I also want a set. Ooh, here's the question. Let's see. Material property block set vector array. Set vector array property. Beautiful. So we want to do a set vector array here. Ooh, actually, terrain patch indirect. Yeah, we can clean this up. We want to do indirect data. To array. So yeah, this is basically what we want to do here. Set vector array. I'm gonna run back to my engine and hug my C++. Well, all of this is very experimental. It's gonna be pristine clean. It's going to be cleaner than C++ in the end, I promise you. Factory. Yeah, let's call this one index 16. And then we do index.x and index.y. Dude, C# is way cleaner than C++. But yeah, agree to disagree. Index instance id.x might work, probably won't, but let's see. So what we want to set here is index. Let's go with a capital I. Actually, can we do index? Yeah, I get it. Yeah, to be honest, like, this is the first time doing serious terrain generation, and it has been quite fun, but it has also been like frustrating, and I've learned so much. And right now, like, this procedural, or not procedural grass, but terrain base and terrain patch indirect both are a mesh, because we have like it feels like we do something and then we pivot in a new direction, redo it, and add something, then we pivot in a new direction, redo the previous thing, and add some new thing. But so like now we're in the process of getting it to work, and then we're gonna clean it up, hopefully. Many programmer nerds have lost years on terrain, so don't feel bad. No, I don't feel bad. It's a learning experience for me. Okay, so index. So what we want to do here is set vector array index, and we want to do terrain patches, terrain data, select D, and not object to world, but here we want to do, actually, how did I store it? Oh, come on. Public vector2 index. D.index. Yeah. Oh yeah, it's a vector 4. Yeah, let's save it as a vector 4 then, but can we do this? Will it complain? What I like about rendering the terrain with these small instances is the frustum culling and clean update of the instance info per chunk. Yeah, that is probably true. Like you get, it feels like you get so much for free by splitting your terrain up into these instanced chunks. Yeah. Ooh, 67. What kind of problem is this one? Hi, text 2D. Yeah, so how do you want me to read the texture with this? Oh, yeah, we need to do... Oh, this is what was the problem. Is it text 2D LOD, I think. And then we need... We're just gonna put 0 here for now. I thought. Oh, it's a float 4, so we want to do float 4 UV 00, maybe? Yeah, there we go. Well, the GPU is good at drawing copies of objects with small variations. Indeed. The GPU is... I love it. I've said it many times before on stream, but one of the things I respect the most, like the type of developer I respect the most are the ones doing algorithm implementation on the GPU. So what do you call it? Functional shaders. What's up, Devs Bias? Hope you had a nice stream and thank you for the raid. Okay, so we don't have any errors here right now. That's good, but we're gonna get... This is probably not gonna work. We set the properties, we set the texture. Oh, there's so many things that can go wrong here, so let's try it. Okay. Shall we? Okay. '63, we have a null exception. Terrain base indirect. Yes. What was it? 93. One of these are null. Which one is it? Actually, do we... Terrain patches. How big is a patch? One patch right now is... Ooh. That is true. Beautiful. So, dimension 2000 times 2000. Vertex resolution. We have changed the name of these, so they have become null or 0 again. So we have 2000 times 2000 unity units in world space distance. So it's pretty much 2 kilometers in both directions. We use 2000 times 2000 vertices for the full terrain. Texture resolution here is 64 times 4. 64 times 4. And then we do subdivision 2. Okay. Let's see what kind of error we get now. Ooh. The fuck? Okay, good. Yeah, so right now we use 2000 times 2000 vertices for the full terrain, and we subdivide it 4 times in each direction, which means that we get 500 times 500 vertices per patch. So 250k vertices per patch. It's a lot. But each chunk is also 500 times 500 meters. So maybe you want to make that smaller as well. I don't know. But the good thing here is we actually get something rendered. That's good. Yeah, I'm using 512 per sector. Okay. So okay, I want to try some things here. We want to do the height doesn't really work for some reason. There's so many things that can be wrong here. Well, I hope my info didn't confuse you too much. Nah, it should be okay, it should be okay. Let's see, what do I want to try first here? Okay, so the size is good. Okay, so this is a CPU terrain. I just want it here as a reference. Okay, so the mesh generates in a good way. The position of the patches are good, so this works. This might not work. And one more thing. Yes, okay. Let's pause this. So we might not see height difference in the terrain because we're not actually sending in the terrain data as of now. So maybe we should do that, okay? So we have a variable here called terrain data texture. We want to set this one from the CPU. So we want to do a render params dot matprops dot set texture terrain data texture and terrain data. Okay, let's see what kind of result we get now. Let's see, I started with a single mesh that was 32 times 32 vertices and sampled the origin corner of the 512 texture. Like, we started by doing this. First of all, we started small, so we implemented this using, like, we implemented the terrain with the patches and the seams and everything on the purely on the CPU side, and that went pretty quickly. And then we moved on to try to implement it with instancing, and that's why it might seem that we do this in a pretty weird order. But yeah, let's see. Okay. So it seems like now we get a now we render the terrain as if the full terrain texture has a height of max height for every pixel, and that is a little bit weird. Height value, so it seems like each value here is 1. Which makes me let's see here. The conclusion I take from that is that we create it here, and then we fill it here. Yes. So texture resolution subdivided is 256 divided by 4 in each direction. So this one is 64, and we do I times 64, J times 64. That is the patches, and we do plus K, which is terrain data texture width. Like, this seems to be correct. Would love to take a look at this texture. So let's do I wonder if we can do let's just try and do, to test this, we can do what? Serialized field, private, render texture. Running on, well, I have to crash, have a good one. You too. And thank you for all the input. I think we're gonna reach a acceptable result in the end. Terrain data test. So basically what I want to do here is, when we have created this one, terrain data test dot set I think I want to do one more thing. Actually, after we fill this one, we need to do, this is very important, in the end here we need to do terrain data dot apply. So this might be what we missed to do actually. So what this one does is that it copies the texture data on the CPU to the GPU. This might very well be the problem we had, or why we're not getting the correct result. So let's see. Beautiful. That was actually the cause of it. That is fucking great. Although it's hard to see the actual variation in the terrain, so we're gonna do this. We're gonna do... Oh, I love this. Within the shader, we're gonna output... We're not gonna output 1111 here. We're gonna output... We're gonna read the texture once again, but not with LOD here. And we need to calculate the UV once again. Output the normal. We're gonna wait a bit with the normal. We need to calculate it first. We're just gonna output the height value for now. But eventually, yes. I want to do this in small steps. Text 2D, terrain data, texture float to UV, height value, height value, height value, height value. Whoa, can we actually not? Oh yeah. Ooh, can we not? That is true. But okay, UV here, we just send it onwards, right? So float to UV text chord, and we do output.uv is equal to UV. And then we don't need to do this, we just do input.uv. Unexpected token. There we go. Yeah, let's see what we get. Beautiful. Beautiful. I also want to try this with... I'm a bit shocked actually that we got it working this fast. So the current terrain data texture to the height we're trying this with is tileable. So we're gonna try it with a untileable one. There we go, and we can see that the meshes works perfectly. So here we can see, beautiful. And this is actually, okay, so this is what we had at the start today, but the difference being that we work with a one big texture 2D instead of a texture array. Yeah, no, Cooler SK, I'm perplexed. We did so many changes and it pretty much worked instantly. Not instantly, but you get the meaning. So before I continue here, fuck, that's such a weird link. But you probably want to read this. Okay, I'm not going to click it now, but we're going to store it in the notepad. Okay, but before we continue here, I need to run AFK real quick. I'm gonna make a new cup of coffee because we're gonna deep dive into this, and like what I'm seeing here with the seams, I already love it. So yeah, be right back real quick. And I thought you were supposed to crash Goblin. Be right back. Okay, back. Sorry about that. Needed to do an additional thing. But okay. New cup of coffee, and I'm ready. And I love what we're seeing here. So, fuck, do I want to clean this up before we implement something more? Yeah, and Render Goblin, I yawned and stretched and got 10% energy recharge. That's very nice. Grey desert indeed. Okay, so before we continue, I want to do some cleanup. Because this is a mess right now. Terrain patch indirect. We don't even need terrain patch indirect anymore. We don't use it. We pretty much just use terrain patch indirect data. Index here. Okay, name. I think. And I want to rename this one to terrain patch indirect. Okay. So actually, one sec. Did I... terrain data test, we don't need that one. Terrain data textures. These are pretty much just an array of test textures. Oh, actually, before we continue with the cleanup, we might want to try and add some different textures, still see if we get the correct result, or the result we anticipate. So each terrain patch should be able to have its own height map, and I just want to try that real quick. So we're gonna make this into we're gonna add 3 different height maps and play it. It looks to be all right. Very nice. Should have opted for a big 2D texture from the start. Don't really know why I didn't. Yeah. What's up, modding Minecraft? Max height delta, UV delta. It's this one we use, right? We don't use delta. We use index, which I want to rename modding Minecraft. Our GC got leaked. What do I do? What do you mean by GC? I think we're going to rename this one patch index. Makes much more sense. Patch index. So patch index, and we don't need this one. Group chat. I don't know modding Minecraft, but I wish you good luck. UV Delta, maybe not the best name either. Ooh, did we could probably skip sending this one. Let's see. UV Delta, it's it's pretty much one divided by subdivision. That's what this one is. So I wonder if we want to rename it that. Or let's see. Or something like patch length UV. So it's patch length, but in UV space. I don't know. Texture resolution subdivided. Do we need all of this? Yeah, we do. Delta, we don't. Up. We might want delta. Like now I want to try and recalculate the normals, but I want to do it on the CPU. Get it down to the, like send in an additional texture. Just get the exact same result we had yesterday, and then we might move away from that. Do it on the GPU instead. We'll see. Terrain shader indirect 59. I thought we... Okay. Nice. I do want to clean this up a bit more. Subdivision. Dimension subdivided. Okay, so for now what we're gonna do is for int I is equal to 0, I is less than actually 1, I is less than terrain data dot width -1 plus plus. And we want a, let's see here, terrain data, private texture 2D terrain normals. Texture 2D. We just want this once again, I think. So for each frame here, we're going to calculate the normals, and the way we do that is let's see. We could probably go to, no, we can't, or we can. Patch indirect. Copy deleted lines. We're gonna get way more than we want. So let's just copy this. And then yeah, we want to do height here. We don't have height right now, so we might do I want to implement this one? Height range dot lerp terrain data dot get pixel ij, or actually xy dot r. And then the normal is equal to, yeah, we need to figure out this delta as well. It's extremely important that the delta is correct. But here we're gonna do terrain normals. Okay, let's see. So delta x and y. What is delta here? It's dimension subdivided, vertex resolution subdivided. Yeah, I think that's okay. And yeah, probably want to do this on the GPU. But let's see if we can get the same result we had yesterday with this. So after all of this, we also need to do terrain normals dot apply. And finally, we need to send this data to the shader. Although render, we don't need to do matte props. We can just do, or actually, I think we can just send it in, set it in the material itself. Because they use the same texture. But yeah, for now let's do terrain normals. Yeah. Did we just call it terrain normals? Oh well. Yeah, we want to sample it here, and it's in object space. But we need to sample it with this one. UV, RGB. So normal in world space. Here, let's just do return input.normal world space times 0.5 plus 0.5, I think. Here we change it from -1 to 1, 0 and 1. Okay. Okay, same problem as yesterday, I think. Actually, yeah, let's compare it once again. So, garden, let's change it to 100 times 100. Regenerate. Yeah. And this is 64.2. Whoa, actually, okay, so this is the exact same problem we had yesterday. Let's see if I need the 2 hours again or not. We read the normal OS from the texture, so it's between 0 and 1. We change it to be between -1 and 1 here, and then we transform it to world space. Down here then we have in world space, we just want to bring it back to between 0 and 1 again. Okay, so this should be correct, but we're not getting the correct results. So my question then is terrain base indirect, are we using the correct delta? That was the other issue we had. And let's take a look at terrain patch indirect. Check this. Oh yeah, of course. So texture data has the normal 0, 1. Yes, the problem we have here is the delta we use here. It's based on vertex resolution subdivided. What it should be based on is, if I remember correctly now, it should be texture resolution subdivided, I think. We're using shorter, like we're giving it, we're pretty much telling it that the distance between points that we base the normal calculation on is shorter than it actually is. There we go. It looks to be, yeah, it's a tiny bit more distinct here, isn't it? But then again, okay, let's take this one, garden, and let's do 2000, 2000 and regenerate. And -2000. or let's go it's a win, ship it. Yes, we'll see. Okay, are they more alike now? Yes, I think they are. We get these artifacts here, but that's to be, yeah, like it's extremely high resolution when it comes to amount of vertices, but it's extremely low resolution when it comes to height map and normal map. That's why we're seeing this. So yes, okay. So now we're pretty much back at where we were yesterday, but with the very noticeable difference that we're using, or actually we're a few steps ahead of where we were yesterday. So instead of using texture arrays for terrain data and terrain normals, we use a big texture. Yeah, I think that's better. I'm gonna try and move this down to the shader. And we also have, since we're using one big texture for the terrain, we pretty much don't need to worry about getting the seams correct. So the end of the world, the edge of the terrain, will have a tiny artifact, or it has right now. It probably won't when we do this on the GPU actually. That is true. But yeah, so this is very nice. So Render Goblin, how when it comes to your terrain, how exactly do you handle like collision with objects? Okay, so let's do, I wonder if I want to do, yeah, let's do it like this. Oh, I want to try one thing first. Render params matte props set texture. I think we want to do I wonder if we want to do material dot set the fuck. I wonder if we want to set like max height, patch length UV, and these two, they don't vary between patches. I just sample the height data and do intersect math. Beautiful. That was what I was thinking. Yeah, great, 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 great. Okay, so I think this is what we want to do. create the render parameters with the material, and for the material we set these are going to be the same for each instance. World bounds I'm a little bit worried about, but yeah, let's worry about that one later. And then we do set matrix array and set vector array, so these are specific variables per instance, or where each instance need their own data. Great. If I was doing physics sim with balls rolling down hills or something, I would probably do some ray versus triangle or plane intersect kind of stuff. Yeah, we'll see what solution we will use. I do think height, like just reading the height map, should be good enough, but I don't know. Okay, great. So what I want to do now is we're going to move on to terrain shader indirect, and we're not going to read the terrain normals like this. We're going to read it manually, or we're going to sample the height map. In a few different ways, and we're gonna do we don't require this one anymore. Do we need a patch delta UV here? I think. Basically would like to have something like float 3, calculate, oh, we've done this so many times now, calculate or approximate from approximate normal from connected neighbors. float 2 UV. That's all we need, right? Yeah, and basically what we want to do now is terrain base indirect. We want to move all of this to the shader, but it's going to be but we need some offset here as well. And the offset, we're gonna have to send into the shader. We're gonna have to send in the yeah, we need max height as well. Okay, what do we want to name it? So it's basically going to be 1 divided by terrain data texture dot width Red Goblin, oh yeah, got a crash for real this time. Have a good one. Rocket. Thank you. You too. I wonder if I want to call this delta UV. Let's just call it this one, like this for now. And let's see here. So up should be UV.y plus delta UV.y. Down is minus. Right is .x. and left is minus dot x, and then we have up right, so that's plus, plus, and then we have down left. Okay, so we do the exact same calculations for approximating the normal with connected neighbors, but here we do it in the shader instead. We need to send this delta as well, I think. So delta UV, and I think I want to call this float to delta world space. That's pretty much what it is. So delta UV, that's the delta length in UV space. This is the delta length in world space. Pretty damn sure. And that's what we want to use here, 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 here. Yeah. And then we don't do it like this, we do normalized. And here we, yeah. So, okay, this is nice. New vector 3, we call this one, let's do float 3. Actually, we can just do return float 3, but also normalize. I think that should be it. Now we need to send in both of these though. So let's do that. Ooh, no errors. Nice. So set vector delta UV, and then we wanted to set delta world space, and probably want to move most of this down here later on as well, but whatever, because we want to use, let's see here, delta dimension subdivided, texture resolution subdivided. This delta right here, this is delta world space, and private vector to delta UV. So delta world space, and then we do delta UV is equal to, I think it's just 1. Let's see here, vector 2 dot 1 multiplied by divided by let's do it like I think this is the correct values for it. So delta UV, the step between pixels pretty much. Delta world space, that is the step in between pixels but in world space coordinates. Okay. Okay, great. And then in our shader, we want to, like we have this method right here. We calculate a approximate normal in object space though, but that's okay. So we do normal OS. Instead of reading a texture here, we do approximate normal connected neighbors UV. That's our normal OS. We send it to output, and here we do output normal. We don't need to transfer this one from 0 to 1 down to -1 and 1 now, because we actually calculate it here between -1 and 1. So we remove this. So transfer normal from object space to world space, and then normalize it. Send it down to the fragment shader, and here we output it. Let's see what we get. Fuck, is it the correct result instantly? It pretty much looks like it. Yeah, I think it is. This one is a little bit more smooth out, but other than that, we have a good result here. Nice. We do actually do it on the... beautiful. So what I want to do now is like 6 texture reads. We can get it down to 4, and then if we want to approximate it even more, we can get it down to 2. But I want to add the 4 neighbor approach as well. Although I need to check what kind of frame rate did we get here. Did we lose a lot or no? I think it's okay. Okay. Okay, I think I want to go with a flag here. Let's see. Do I have one in cell shade lit? No. Do we still have one in procedural grass light? Grass fidelity, good. Shader feature. Terrain shader indirect. do think we want something. Let's see here. Properties. Low, medium, high. I wonder if we want like normal approximation neighbor count. Or low, medium, high, ultra. And then we go, or actually 4 neighbors, 6 neighbors, 8 neighbors, maybe. Normal approximation fidelity. Low, medium, high. Let's try it. Can we create a new line here for each? Do we get an error with the new line? Oh yeah, we can do it with new line, right? But we need to do... Can you do it like this? Yeah. Connected neighbors. Okay, let's just do it. So float 3 connected neighbors. Here we do 4 neighbors, and then we do 8 neighbors. What's up, Fabic? 4 neighbors, connected neighbors, 8 neighbors. Up, down, right, left. How's the progress going, sir? It's going... It's going forward. It's going forward. So pretty much what we've been doing today so far is terrain base indirect. Yesterday we worked with when we sent the terrain data down to the shader, we worked with a texture array. So far today we have repackaged that texture array into a texture 2D. And we use that instead of array. I think it's going better, and now we're implementing normal approximation in the shader instead of on the CPU, basically. And what do we want to do here? We want to do cross between, what is it? Right minus left and up minus down, I think. Upright up left and down right. And here we want to do, what's it, cross between right minus left and up minus down plus cross between up left minus down right and up right minus down left, I think. We'll see. And then we do if def, we're gonna do procedural grass. Just need to check this again. Jesus. Maximum quads per blade. This is how we do it. If def, elif, blah, 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 blah. So I wonder if we want to do we could have had all of these in the same method actually. But for now, let's just do it like so if medium, we calculate the normal by doing connected neighbors. If high, we calculate the normals by doing 8 neighbors. I think that should give a better result. And if else, so low, then we just do 4 neighbors. Yeah, let's see what we get here. So we have environment materials, terrain, default, indirect material. And we have low, medium, high here right now. I'm a little bit worried about this pink color here. Low, medium. Okay, this is not good. High. Do we need to have one sec. Do we need to define A little bit worried about this one. Is it? Oh, never mind. There we go. Okay, I wonder if it was probably this one, right? Yeah. A little bit weird that we didn't get an error. Okay, this is low, medium, high. Let's see. We calculate normal OS. Yeah, we might need to do more things here and here, but medium should still work, but unfortunately we're just getting pure black. No idea why. Probably not calling this one. I don't know. Approximate normal connected neighbors, UV. Okay. Okay, so this works. What if we do back to this? Did I comment? Okay, we could keep it like this. Then we get pure black. Do we need to world normal material? No. Terrain default indirect material. If we do approximation medium, if this works, we will get connected neighbors. So this one, the one we had. Great, and if we change to low, we get this medium, high, also get black. Yeah, these are, yeah, of course. So these are just single float values. Yeah, that's not good. We want to do delta VS. I wonder, so we want to work with yeah, what we want to do when we work with it like this is we don't want to do cross. We want to do, what is it? Float 3. It's left minus right. 1.0. And up minus down. Is that how we want to do it? Low, medium. Not entirely correct. High. Although this one low currently looks like this one, the bubble in the middle was just used to double check the world normals, so that we had roughly the correct normals. Although I do wonder why low here doesn't give the correct result. We should be seeing something similar to medium, but with a little bit less. Is it down minus up? Ooh, nah, still not correct. Medium, low. Actually, just while testing this, let's skip these if def and so on and do comment it out and do and low. Okay, so this is definitely not the correct ones we want for low here. Approximate normal for neighbors. I wonder though, right minus left, it should be something like this. But then again, is it this one that makes it so that it doesn't instantly reload? And one more thing, I think we need to... Yeah, I think we definitely want to have... We want to remove the max height here as well. Okay, better. But fuck, it's incredibly weak, isn't it? Now I would like to be able to compare low and medium. But they give the same. Okay, so let's go back and do... Okay, let's try this. So this is medium and this is low. Yeah, low is a... It's not entirely correct, but it's getting closer at least. I think we're having... I wonder if we did it the correct way here. So right minus left, up minus down might be the correct one. Like, if I'm gonna be honest, I'm probably gonna rely on this way of calculating normals the most, and we might just want to simplify it down to 4 or even 2 texture reads if we notice that the performance is starting to lack. I don't know about this one. Is the terrain actually so big that we're seeing... Yeah, it's outside of, let's see, camera node, far 1000. Yeah, that... I'm thinking of I need to look into more how to properly approximate the normal. Let's just keep it like this for now. Approximate normal connected neighbors. Okay, so if we do this, we don't need terrain normals texture. Is there anything else we don't need? I don't think so. And then we jump to terrain base indirect. And we can probably remove this, and this. And this. I'm still, so if we do delta W and delta world space, let's see, we calculate them here. And then we don't use them anywhere else. What do we need here? Texture resolution. Okay, so delta UV we can probably calculate here as well. We don't need it as a variable up here, or property. Delta UV, delta world space, probably. Fuck, I wonder if... should we start doing some terrain terraforming soon? I think we're starting to get ready. Maybe first of all get some simple lighting in place, and then we can do... I wonder if I want to do some simple... We're gonna need to handle the collision as well. So, like worst case scenario, you could do... generate a mesh collider based on height map data. Okay, so I want to get... I'm trying to figure out in what way I want to do this. I definitely want to do terraforming, but we need to get the collision in place again. So the most straightforward way to do collision would be to just create a mesh collider based on the height data. That's what we did previously. But I've been thinking about doing it with, let's see here. Let's see. This one, like using the terrain height texture to calculate ground collision for entities instead of doing it with a mesh collider. I wonder. Yeah, it shouldn't be too hard, I think. Let's see here, implement per instance normal map generated using naive approach, but it's, yeah. Actually, this one we haven't fixed. Yeah, this one is fixed. So pretty much by reordering the height map and by reordering the height map from a texture array to a texture 2D, we pretty much fix this and don't ever need to think about this anymore. Very nice. So unfortunately it's that time again. I need to go soon, but what we're gonna do tomorrow is we're gonna start by doing implement basic Blinn Phong light calculations. It's going to be a little bit of an adventure since we can't rely on the usual HLSL functionality I do, but it should be possible. And when we have that in place, we're going to do implement, actually I want this one here, implement ground using mesh collider, just get it up and running, make it work. Implement ground collision using the height texture. So we're gonna do this, then this, just to make it possible to run on the terrain once again, and then we're gonna do this. I want to have this one ready so I can compare the functionality of this one with this custom implementation. And yeah, when we have that in place, actually I want to implement Blinn Phong here as well. I want to have both of these approaches available to me, so simple terrain generation or naive with using mesh filter and mesh render and such. I want to have both of these. So when we get this one working and these working, then we're gonna do implement terrain. What did I call it? Terrain terraforming. And we want to do it in naive approach, in GPU instanced approach. Fuck yeah. Okay, so yeah, unfortunately I need to run now. We'll be back tomorrow. Hopefully with some quick Blindfong light calculation, then some quick collision, then some experimental collision, and then finally terraforming. As always, thank you so much everybody for watching. It's really appreciated, and hopefully I will see you tomorrow. Have a wonderful rest of the day. Peace.